Hi friends, so today we're gonna check out this ROT13 kata. It's a simple letter substitution cipher that replaces a letter with the letter 13 letters after it in an alphabet. It is an example of a Ceasar cipher, and if you know some more about cryptography, that probably makes a lot of sense to you. I happen to know the Ceasar cipher. It's like extremely basic, and I guess that's a really cool merger of two fields like cryptography and learning to code. So I think it is a really good and interesting kata. All right. So what we have to do is basically we have to create a function that takes a string and returns the string ciphered with this ROT13 cipher. If there are numbers or special characters included in the string, they should be returned as they are. So that's important. Okay, so we don't have to care about anything else except for letters. And they say that we only have to care about the Latin and English alphabets. Okay, so that's cool, I guess. That gives me an idea that we should probably be using regular expressions for it. But still, what I always like to do is first, I really like to start with the tests. And it's not because I'm very huge advocate of test-driven development, but more because the tests really give you some time to really think about your solution, how you're gonna solve this problem. And I guess what we're gonna do is we're gonna delete everything. Okay, that's what I always do. I always try to delete, start from scratch. I think that's a bit better learning experience, just because you don't rely on pre-written code by someone else. What I also like to do is use this chai assertion library, and we have to import it specifically in Codewars. So that's what I'm going to do right now. Yep, so all what this first line did was we got the expect out of the chai library. Then follows, you never guessed, our describe statement. And we're gonna describe the ROT13. I guess that's the name of the function. I'm using the ES6 style arrow functions right here. Some people and some documentation say that probably that's not always it's safe to use it, but in these simple cases it's perfectly fine. And I had test as the initial test. I don't want to calculate the actual how actually these letters will be substituted, so I'm relying on the pre-written examples. Okay, so I am expecting, the expected is GRFG, right? And then finally I expect that the ROT13 bit test is gonna be equal to the expected. Making lots of mistakes today. Right, so that's our first test. Let's do one more, just because two tests are provided for us, two solutions. So I guess that's a good idea to test the uppercase too. So let's do like T-E-S-T, like that. Then we have function. And the expected, can you guess it? Yes, it's gonna be exactly the same thing, just with the capital first letter. And then expect ROT13 with test to be equal to the expected. Okay, so test gave me like a little bit of time to think about it. First of all, we will have some challenges with cases. I mean that uppercase and lowercase letters should be distinguished, right? Also, I thought that letters like T and then like S and like letters further than the middle of the alphabet, right? They have to like start from the beginning again, right? So we have to like, we cannot really go over the Z. Also, what I thought is that we can really have to distinguish between like in this uppercase versus lowercase. What can happen is what if let's say uppercase letter Z gets shifted by 13 ANSI codes. What will happen then, right? So it will go into the lowercase letter space, and that can cause problems for us. So we have to like do a test before and test after. And I guess if the test if we test it for like lowercase letters before, that means that the letter has to stay lowercase after it is shifted, right? The actual thing which I probably like haven't mentioned that, but actually what my approach would be initially is to check if it is like a letter, okay, if it's like a lowercase or uppercase letter, and if that's not the case, then we just return whatever was there initially. Okay, so that's like half of the exercise done. We filter out all the symbol spaces and whatnot. We just care about the letters. Then if it is a letter, I guess what we should check if it is a lowercase letter. And if it is a lowercase letter, we try to shift it. And if that so happens that after the shift, it becomes like it is not a lowercase letter anymore, so we have to shift, but in another direction. And how that will happen is I'm going to expand this this area for my functions and delete everything. How this shift in another direction, how it will happen is, luckily, like we probably all know that there are 26 letters in the alphabet, and if you shift to one direction by 13 and you go overboard, that just means that like whatever you basically you can shift by 13 letters in to the left or to the right. That will basically give you like a correct solution for all the letters after the middle one. I don't know which one is like the middle letter, which is the like cutoff point. And I guess we can make the solution like much simpler if we would know that. But let's not do it. Let's do it like, let's imagine this do this exercise, like imagining it can be used for like other alphabets, and you don't have to like hard code anything. Just have to have like good regular expressions and good checks, and it will still work with updated alphabets or whatever other cases. So I try to write my functions for some reason with this syntax. I store them in variables, and I have to name it ROT13, and I have a message, right? So a message is my one parameter which I get, and I immediately return something. Let's think about it. How we gonna tackle it? We're gonna tackle this message like symbol by symbol. So I would just not always, but a lot of the times I use reduce. I split the message, and we're gonna split it at every character. That's why we have this empty string right here, and then we're gonna use reduce to help us to really like tackle every single character. And I'm naming my like this previous value, some people call it, I just like to call it result, and current value, I call it value. So, and this time we're not gonna return anything immediately. We just gonna like have this fat arrow function, and inside the body we're gonna do all the calculations with what we need. Also, I am providing an initial value because I don't want it to be like the first value. That's like absolutely incorrect. I just want to start out with an empty string, okay? Because the result is going to be a string, so empty string, perfect starting point. So first of all, what I think I'll do is check if the value is a letter. Then, if not, then just return result plus value, right? So we don't really care what else is it a space, is it like a dot or whatever. We just return it added to the end of the result. So I'm going to do it using regular expressions. And I'm not like super good on regular expressions. I don't think that... I know some people are, but they're few and far in between. So I really try to keep my regular expressions as simple as possible, and usually don't use them at all if they would be like too complicated. Luckily, in this example, it's not going to be the case. They're very simple. Let me explain this regular expression like symbol by symbol. First of all, we're gonna just check if between these brackets is what we want to like check one or the other. So we want to check if there are lowercase letters, so a-z means the range between the lowercase a to the lowercase z, or the range from uppercase a to the uppercase z. And this hat symbol, right, that just means that it's negation, right? The same as an exclamation mark in JavaScript. This just means that whatever we have here, it's gonna be not that. Okay, so no uppercase or lowercase letters. And we're gonna test that. So if that's true, what we're gonna do is we're just gonna, as I said, return result plus value. Then what we're gonna do now is we're gonna check if the value is lowercase. Okay, because we know it's a letter, like it's just uppercase or lowercase. That's one of two options. So let's check if it's lowercase. So if, again, using regular expressions, this time it's even easier. It's anything from A to Z, right? And we're gonna test value again. And if that's true, we're gonna return something, right? If that's not true, so there are two ways to do that. If you want to just have like two cases from A to Z, it's perfectly fine to use else. It's perfectly fine not to use like anything, since we're gonna be probably returning something right here. So if it's already returned, the function does not continue. Still, what I'm going to do is I'm going to be like just in case I want to update this to like accept different kind of parameters, I'm just going to make it very explicit that I'm testing if it's an uppercase letter. Of course, as I said, that's always going to be the case. If it's not lowercase, this one will always pass. So that's really a useless check, but imagine we would have A to Z lowercase, A to Z uppercase, and numbers from like 0 till 10, right? That immediately requires this type of approach. So that's a bit of overkill in this example, but I like this approach just in this case. So here we're gonna check if the value is uppercase, right? So we have like we know if it's lowercase or uppercase, right? I guess now it's time to actually try to shift it, right? So let's work for now just with this lowercase section and try to implement that to pass our first test. Because our first test just deals with lowercase letters. Let's try to pass that. We already know that it has to pass this lowercase letter test at the end. So we have to figure out a way to shift the actual letter by 13 like iterations or 13 numbers. So what we're gonna do right now is try to get the code of our value, right? So to get it, I'm creating a new variable called shifted, and I get the code from like the ASCII code from a char using this function called char code at. So value char code at, and basically it works on like strings of a different length, but the default is 0, and we know that that's just going to be a single symbol or a string with a length of 1. So we don't pass any parameters here. So what I got right now is I got the char code, the char code basically at this for this letter, and I'm going to shift it by 13, right? Also, I kind of still have a number. I need to convert this number back to the letter, okay? And we do that by using another like function, and it is under the string like variable, and it's called from char code, okay? And what happens right now is first, this one gets evaluated. We will get the char code at this, what the char code is for this value. We add 13, we get like 22, let's say. And we get the char from this code 22, and that becomes shifted. Can we just return the shifted right now? Unfortunately, no. We still have to check if the shifted is a letter, and is like not a letter, a lower case letter specifically. And how do we do that? That's very easy. We already have this test, right? So we're gonna just replace this, like copy and paste this test. And what we're gonna do if that's true? Oh, also, it's not valid. It's gonna become shifted now. So if shifted is still a lowercase letter, it's very easy. Return result plus shifted, right? Else, and we basically, since we have the return statement right here, we know that this will not happen in any other case, so we can return. Well, how do you deal with this one, right? Remember that I said that we're lucky since it's like ROT13 because it's right in the middle of our like alphabet. So what we can do is we can shift it in the other direction, right? So if we shift it by not plus 13 but minus 13, we will get the correct result. If you can, I encourage you to check that out. If you don't believe me, it's still gonna work, okay? So that's all good. Let's try to pass our first test. What do you know? Didn't work. Let's try to debug it. And stupid me, I kinda had to have this result plus this string, right? Result plus string from char code, that should give us the correct result. Let's see if, oh, this one's all right. That should work. So let's run the examples. Right, so we passed the first test. Unfortunately, this undefined, we still get the test 2, test with like uppercase letters or capitalized strings. They don't work. Okay, so let me continue, and we have to implement this section too. Very easy way would be just, let's do it very easy way. No, why not? Let's just copy everything what we have right here. It has to be just uppercase, and we have to check it for a different result, right? Let's try it out. Excellent, that worked. However, you might be thinking, wow, stop what you're doing. You should not be like copy pasting code all around. That's not very dry. And I'm repeating myself quite a lot. And a perfect thing to deal with it is just to create a function. So I'm going to create another function inside this first function. I'm going to name it shift same case, right? And let me think about it. It kind of has to have this regular expression, right? And it still has to have this initial value, so 2 parameters. So first of all, let's have the first one char, and the second one, let's name it test, okay? Because that's going to be a string, not passing regular expressions. I think I'll create one immediately inside the function. It's like more readable to pass this test as like strings, in my opinion. I might be wrong. I just prefer it this way. You might be wondering what's happening right now. This regexp, this new object, just creates a regular expression from a given string. So we pass it this test. This test, what is going to be? It's going to be like this section, sorry, this section, or this section. Okay. So I have my regular expression. I am just going to create this shifted variable again, right? So I can basically copy paste it. Just I have to make sure that it creates it not from value which is not available for us, but from which is, by the way, available for us, but it's in the upper scope. I wanted to use this char, right? Because the char is what we actually care about. Lastly, I'm going to do this check. So if this regular expression tested for shifted, right? If that's true, I'm going to return shifted, right? If that's not true, right? So right here, I'm going to return this whole same thing, just -13. And I might be like, can't avoid creating the shifted variable, but we're using it 2 times right here and right here, so I think that's okay. I'm not going to create like shifted in other direction variable just to use it once. I can't create it, create it and immediately return it. Okay, so we have our function. Now let's update the code to deal to like use this function. So first of all, I am going to delete everything what I have right here. Okay, don't need that. And I'm actually going to do that in line. I'm going to return the result. So it's either way it's going to be result plus shift, right? Same case. And I pass, first of all, the value as a parameter, and second of all, I'm passing this AZ. Okay, and exactly the same thing for this other one. So I can just delete all of that, right? And copy and paste this one. And if that's AC, it should be AZ here. Of course, you might say there are still a lot of ways to like improve this code, and you would be right. You can just try to. You would lose readability on one hand, but you can just probably create this whole thing on a single line of code. Just like extract this function outside, then do like this ternary check operator if it's one of that, or one of that, and return whatever you have right here. Okay, so all the time it's going to be result plus something. So that's a pattern which we are kind of repeating, but I think we would lose like some readability, and that's up to you. You can like refactor this code to look nicer. Let's see if it still passes. And yeah, it still does. Let's run the suit. Still works. Great. So that was how to solve this ROT13 kata.